Today in the workshop we'll be working with an improved H-Bridge Motor Controller. We'll see how to use the TB6612FNG H-Bridge and how it provides better performance than the popular L298N. We're building better bridges today, so welcome to the workshop. Hello and welcome to the workshop, and today we're going to be controlling a couple of small DC motors using an H-bridge, and we'll take the whole assembly and we'll put that into a robot car base. Now if this sounds a bit like deja vu, I'm not surprised. We've done this several times. In fact, a couple of years ago I did a video about doing exactly what we are doing today. Plus we have done a number of videos using small robot car bases, and in all of these videos there's been one common element: the L298N H-Bridge controller. Well, today we're going to do all of the above with a different H-Bridge controller, the TB6612FNG H-Bridge. Now the TB6612FNG, or I'm just going to call it the TB6612 for short, is a MOSFET-based H-Bridge, and it's available in a number of inexpensive modules, just like the L298N is. And one beauty about this H-Bridge is that it has similar specifications to the L298N, so you can use it in a lot of the same applications. In fact, it uses similar control signals, so it's very easy to take an old sketch that you used with the L298N and move it to this H-Bridge. Well, why would you want to do this? Well, this H-Bridge has a number of performance advantages because it uses MOSFETs and not bipolar transistors. So let's take a look right now at the TB6612FNG H-Bridge. So let's take a closer look at this motor controller module. The TB6612FNG is a dual-channel H-Bridge motor controller. The device is constructed with MOSFETs for improved performance over devices constructed with bipolar junction transistors. It has a motor supply voltage that ranges from 2.5 to 13.5 volts. The logic supply voltage can range from 2.7 to 5.5 volts, making the device compatible with both 3.3 and 5 volt logic. The TB6612FNG has an output current of 1.2 amperes continuous with 3.2 ampere peaks. This H-Bridge module has four functions: a clockwise rotation, a counterclockwise rotation, a short break function, and a stop function. Now let's take a look at the pinouts of a typical TB6612FNG module. You'll note that with most of these modules, the outputs and the inputs are on opposite sides of the module. The VM connection is the motor voltage input. The VCC is a logic voltage input. There is a ground pin. A01 and A02 are the outputs to motor A. B01 and B02 are the outputs to motor B, and there is an additional ground connection. On the other side, the PWM-A is the A-channel PWM input to control the motor speed. The AI1 and AI2 pins are the input controls for channel A. This determines what mode the channel is in. STBY is the standby input. This allows you to place the device in a low current standby mode. BI1 and BI2 are the B-channel input controls. PWM-B is the B-channel PWM input, and there is an additional ground connection. This H-Bridge has built-in thermal shutdown. It also has low voltage detection circuitry. The device has a standby power mode, which allows you to place it in a very low current draw mode when it is not being used. The TB6612FNG is available in many popular modules, shields for the Arduino, and hats for the Raspberry Pi. So now let's take a closer look at one of these modules. Now here we have a TB6612FNG module, and as you can see, this is a very tiny device. Now they package it like this along with a couple of male header pins that you can solder onto it, and I've soldered a couple onto this one over here. So as you can see, they've got on this particular style all of the connections written on the bottom, which makes it a little more difficult when you breadboard. Now SparkFun makes a module just like this one, and they also have the silk screening on the top, and you might find that a lot easier to use. But as you can see, it is a very tiny module. Now here's an L298N H-Bridge Motor Controller by comparison, and as you can see, the size difference, this is about a quarter of the size, plus height-wise, of course, you've got this huge heat sink on the L298N, and there's no heat sink on these devices, although you could put a heat sink on this chip if you thought you were going to be running it at its maximum rating constantly. You could even make things smaller by not soldering the pins onto this and disconnecting wires directly to the motor control module. So a very tiny module to replace the L298N module. So as you can see, the TB6612FNG has a definite size advantage over the L298N, and that is because it is a smaller module to begin with and also does not require a large heatsink, although you can attach a small heatsink to the module if you feel that it is getting a bit too warm. But of course, size, as they say, is not everything, and there are other aspects to consider when you are choosing a motor controller. And so what I want to do right now is just quickly compare the specifications of the TB6612FNG to the L298N and see how they stack up against each other. Let's just go and do that right now. Let's compare a few parameters of the TB6612FNG and the L298N H-Bridge motor controllers. The motor voltage range for the TB6612FNG is 2.5 to 13.5 volts DC. The L298N has a motor voltage range of 4.5 to 46 volts DC. So the L298N can certainly handle higher voltage motors, however it cannot handle low voltage motors such as 3-volt motors, which can be used with the TB6612FNG. The TB6612 has a 1.2 ampere constant current rating. The L298N has a 2 ampere constant current rating. The TB6612 has a 3.2 amp peak current rating, and the L298N has a 3 amp peak current rating. So for current ratings, the devices are very similar. The TB6612FNG is available in very small modules that do not require a heatsink. The L298N is on larger modules that do require a heatsink. Note that there is a version of the L298 that does not need a heatsink, but it does not have the current capability of the L298N. Efficiency is where the TB6612FNG really shines. It has an efficiency rating of 91 to 95%. The L298N has an efficiency rating of 40 to 70%. This means that 91 to 95% of the energy that is sent into the TB6612 is delivered to the motor, whereas the L298N at best delivers 70% of that energy. Incidentally, the efficiency of the L298N improves at higher motor voltages. The voltage drop in the TB6612FNG is very low because of its use of MOSFETs, and it varies over the voltage range. The drop is from 0.05 to 0.13 volts DC. The voltage drop on the L298N is a pretty constant 1.4 volts DC because of the 2 bipolar junction transistors it employs. The TB6612FNG has a low current standby mode. There is no low current standby mode on the L298N. So now that we've seen how the TB6612 stacks up against the L298N, let's actually hook it up to an Arduino and start using it. Now, as I've already shown you, it is very compatible with the L298N, so much so that what I've decided to do is repurpose one of my older Arduino sketches that was based on the L298N and use it with the TB6612. So let's go ahead and take a look at the wiring. I'll show you the sketch, and then we'll run a couple of motors off of our little H-Bridge. For our experiment, you will need an Arduino Uno, a TB6612FNG motor control module, a couple of DC motors that I'm calling motor A and motor B. I'm using 6-volt motors. You'll need a power supply for those motors, so I'm using a 6-volt power supply, and a couple of potentiometers to control the speed of the A and the B motors. We'll start by connecting the 5-volt output of the Arduino to the VCC on the motor controller. We'll connect the ground from the Arduino to one of the ground pins on the motor controller. We'll also connect 5 volts to one end of each potentiometer. And we'll connect 5 volts to the standby lead on the motor controller. We'll ground the other side of the potentiometers, and then connect the wiper of pot A to analog input A0. Pot B will go to analog input A1. Next we'll connect the motor controller control leads. Pin 3 of the Arduino will go to the AI1 connection on the motor controller. On some models this will be labeled as A-in1. Pin 4 will go to AI or A-in2. Pin 5 to the PWM-A input. Pin 6 to the PWM-B input. Pin 7 to the BI or B-in1. And pin 8 to BI or B-in2. The positive 6 volt will go to the VM connection, that's the motor supply voltage, and we'll ground the other side of the supply to another ground lead. And then we'll connect the motors. Motor A will be connected to A01, which is A output 1, and A02, and motor B connected to B01 and B02. And this completes the wiring. Now here's the sketch that we're going to be using to control the TB6612FNG H-Bridge, and as you'll see, this is a very simple sketch. Now we start off by defining the connections to the motor controller, and also the connections to the 2 potentiometers that we're using to control the speed. We also set up a couple of variables that are going to hold the speed of the motors. Now in the setup we set all the pins up as outputs, and we move on to the loop. Now we begin the loop by setting both motor A and motor B forward, and we do that by applying a high to the in1 and a low to the in2 on both of the motor controls. Now of course we could reverse those and make the motor spin backwards if we wished. And then in this statement over here, we're going to both read the potentiometers and convert those values to a range of 0 to 255. So inside the statement, we do an analog read of the potentiometer, and then we're using a map command to convert that from a value of 0 to 1023 to a value of 0 to 255, because that's what we need for PWM. And then we simply pass that value to the PWM pins on the motor controller using an analog write command, and go back and do the loop over and over again. So as you can see, this is a very simple sketch. Now I want to show you another sketch. Now this is a bit of a blast from the past. This comes way back from 2017, and this is a sketch that I used in a fairly similar circuit to control 2 motors with an L298N. And as you can see, this sketch is virtually identical. In fact, the only changes are in the loop. I kind of tightened this up and made this all into one statement instead of 2. But I wanted to show you this because it illustrates that you can pretty well take any sketch made for the L298N L298N and substitute a TB6612FNG. In fact, if you change the input pins around to match your original sketch, you wouldn't have to rewrite any code whatsoever. So now that we've seen our sketch for the TB6612FNG, let's take a quick look at it in action. And so here's our demonstration. As you can see, I've got the two potentiometers. This is A and this is B. And I've got my two motors mounted up here with a couple of wheels on them so we can watch them spin. And this is A and this one over here is B. I've got my power supply, which in this case consists of 4 AA batteries to provide 6 volts. Here on this breadboard, buried behind all these wires, is the actual motor controller itself, the TB6612FNG, and of course my Arduino Uno. And so now that I've got this all hooked up, let's just simply take a look at it working. I'm going to turn the pot for motor A, and as I turn it up, got the speed, and do motor B. And I can vary the speed for both motors. And so as you can see, that works pretty well. Now for our final experiment with the TB6612FNG, I thought it might be fun to take the two motors that I've got and put them onto a robot car base. Now I'm sure you've seen these robot car bases before. They're the little plexiglass or acrylic models that you can get that are very inexpensive and are great for experimenting with robotics. Now in all my previous designs, of course, I've used an L298N when I've worked with these cars, but today we're just going to use a TB6612FNG, pretty well wired up exactly as we saw before with a few slight modifications. Another modification is, instead of writing directly to the motor controller as I did in the last sketch, and indeed as I have for all my L298N sketches, I'm going to be making use of a library. SparkFun has a library specifically made for this motor controller, and I'm going to make use of it and some of their sample code in order to drive my robot car and make it move around the room on its own. So let's go and take a look at the hookup and the sketch that we're going to be using, and then we'll drive our little robot car around the floor. Now for our robot car experiment, we're essentially going to be using the same circuit that we did for our initial experiment with a couple of slight modifications. The first is that we are going to get rid of the two potentiometers. Next, we will disconnect the 5 volts from the standby lead on the TB6612FNG. We'll also require a 9-volt battery. This will be used to power the Arduino Uno in our robot. You could also use a USB power bank if you wanted to, and feed that into the USB supply instead. We'll connect pin 9 of our Arduino to the standby lead on the TB6612FNG. And the 9-volt battery will be connected to the power connection on the Arduino Uno. And this completes the wiring for the robot car. Now to program our robot car, I'm going to take a slightly different approach. SparkFun has created a library for the TB6612FNG, and I'm going to make use of that. Now the library is available on GitHub, as illustrated over here, and you'll also find this link in the article accompanying this video. Now, in order to install a zip library, you download the library into a known location, and then you go to Sketch, and then you go to Include Library and Add Zip Library. Navigate to where you've downloaded it, in my case my Downloads directory, and select the library and click OK. I'm not going to do that because I've already installed my library. Once you do that, the library will now be part of your Arduino IDE. Now there is an example sketch that comes with the library that we can use for our robot car. So go into File, go into Examples, and move down until you get to the SparkFun motor driver library. This will be in the examples from custom libraries section. You'll notice there's something here called motor test run, and this is the sketch that we're going to be using. Now I've got the sketch over here. It needed one modification, and the modification was this originally was set to 2. I have set it to 3, and that's because I've connected my AI1 or AN1 pin to pin 3 and not pin 2. You could also just move the wire over to pin 2 if you wanted to keep the sketch as it is. But otherwise, I haven't modified the sketch at all. Now, the sketch is actually very simple, and it's a very simple way to work with the motor controller. You first of all include the library itself, of course, and define the pins that you are going to be using for the motor controller. After that, you can simply set up an object. They're calling them motor 1 and motor 2, and this is how they're defined. It's motor and then all of the pins in that particular order. After that, you can simply use the functions in order to drive the motors. So there are functions like motor drive, which you pass the speed and the duration that you want in milliseconds. And if you pass a negative speed, the motor will go backwards. So you no longer need to control the motor direction through your code. You just simply pass it either a positive or negative speed. There's also a brake function on it. And as you can see, what they do over here is they simply exercise the motor through a number of different speed and brake and direction changes. In fact, they describe it up over here at the top. It says it'll cause your robot to do a little jig. And so what we'll do is we'll upload this to our robot and watch it do its little jig. And so, ladies and gentlemen, boys and girls, let me present to you probably the ugliest robot car that I've ever seen. Certainly the quickest one I've ever built, and this is probably a good lesson on how not to build a robot car. As you can see, I haven't even bothered to remove the brown paper off of the plexiglass, which normally is the first thing that you do after you make markings on it as to where you want to drill holes. But this, again, is a very temporary thing. I've kept pretty well the same circuit we had before on the solderless breadboard, connected the standby pin to pin 9 is the only difference over here. I've literally used a piece of double-sided masking tape to hold my battery on here. And I've got one spacer holding my Arduino on down over here. Yes, this is pretty ghetto robot car. The batteries over here, of course, are held on. That's actually held down by a screw, but when I put everything together, I found the thing was a bit top-heavy. It kept going like this, so I put a C-clamp on the back over here to weight it down. So this is obviously not how you're going to want to build a permanent robot car, but for this experiment it should work. So I've got my 6-volt power source already connected to the breadboard. My 9 volts is over here, and when I place it onto the Arduino, everything should start up. I'll move it over here a bit. And so as you can see, it does work. Again, not the best robot car I've ever built, but it certainly illustrates that you can use these modules in place of the L298N in your robot car designs. And so with that, we bring to a close our look at the TB6612 H-Bridge Motor Controller. Now, as you can see, this is a pretty versatile device, and I think for most projects it pretty well replaces the L298N. Now, I'm not going to suggest that you go back into your old projects and remove the L298Ns and replace them, although if they're battery-powered projects, you might want to consider it. You will gain some battery life by doing this. Now, if you want more information about this H-Bridge, or if you'd like some of the sketches that I used today, you'll find that on the article that accompanies this video, and that's on the DronebotWorkshop.com website, and there's a link to that article directly below the video. You'll also find a few other links directly below the video as well. One of them is to join the newsletter. This is not a sales letter by any means, it's just my way of keeping in touch with you, and so if you haven't signed up for the newsletter, please do that. If you'd like to discuss this or anything electronic, the best place to do that is on the DroneBot Workshop forums, and you will find a link to the forum directly below this video. All kinds of links. And one last thing, if you haven't subscribed to the YouTube channel, please do that. And so until the next time we meet, please take care of yourselves, and I hope to see you again very soon here in the workshop. Goodbye for now.